All right, today we're going to talk about something incredible, a message from the very dawn of time. And the craziest part? It's hidden in plain sight all around us right now.
So, let's start with a thought experiment. What if that inky blackness you see between the stars, what if it wasn't actually empty? What if it was filled with some kind of faint, ancient light, an echo of creation itself? Well, it is. It's not empty at all. If you have a sensitive enough radio telescope, you can point it anywhere, literally anywhere in the sky, and you'll pick up this uniform glow. This isn't starlight. This is something much older. It's the relic radiation from the Big Bang itself. We call it the cosmic microwave background, or the CMB for short. Now, you'd think a discovery this monumental, right, the afterglow of creation, you'd think it was found by astronomers who spent their whole lives searching for it. But no, the story actually begins with a really annoying, unexplained noise. Okay, so picture this. It's 1964. We're at Bell Labs with two radio astronomers, Arno Penzias and Robert Wilson. Now, these guys weren't trying to solve the mysteries of the universe. They had a much more practical job. They were trying to get a big new radio antenna working for satellite communication. And they ran into this one huge problem. There was this persistent, faint hiss in their signal, a background noise. They tried everything to get rid of it. They pointed the antenna at different parts of the sky, chucked at different times of day. They even, and this is a true story, climbed into the antenna and cleaned out pigeon droppings, thinking that might be the source. But nothing worked. The hiss was just there. It was everywhere. And they had absolutely no clue they just stumbled upon the literal afterglow of the universe's birth. Okay, get this. At the very same time, just down the road at Princeton, a team led by Robert Dicke was busy building an instrument specifically to find this exact radiation. So when Dicke gets a call from Penzias and Wilson describing this unshakable background noise, he hangs up, turns to his team, and says, "Boys, we've been scooped." Just like that. They knew exactly what that annoying hiss was. So, what was the signal they found? To really get it, we have to rewind the clock, way back, to when the universe was just a baby. We're talking about 379,000 years after the Big Bang. Now, the universe back then was nothing like it is today. It was this incredibly hot, dense, soupy fog of plasma. Think of it like being inside the sun, but everywhere. Light couldn't travel freely. It was just constantly bouncing off free-floating electrons and protons, totally trapped in this cosmic chaos. But as the universe expanded, it also started to cool down. And when the temperature dropped to about 3,000 Kelvin, it hit this critical tipping point. It was finally cool enough for those free electrons and protons to get together and form the very first neutral atoms. And here's the magic part. With all those charged particles suddenly locked away, the light was free. Bam! The cosmic fog cleared, and the entire universe became transparent for the very first time. And the light from that exact moment, it's been traveling through space, totally unimpeded, ever since. So when we look at the CMB today, what we're actually seeing is the light from this giant spherical surface all around us. We're looking at a snapshot of the moment the cosmic fog lifted, 13.8 billion years ago. Now you might wonder, why isn't the sky glowing at 3,000 Kelvin? Well, for 13.8 billion years, the universe has been expanding, and as space itself stretched, it stretched the wavelengths of that light along with it. It's like taking a wave drawn on a rubber sheet and stretching the sheet out. The wave gets longer and less energetic. So that original hot light has cooled all the way down to a mere 2.725 Kelvin. That's just a couple of degrees above absolute zero. And that is the temperature of the hiss Penzias and Wilson found. Okay, so a uniform glow is cool. But the story gets even better, because this ancient light isn't just a uniform glow. Buried deep within it are the seeds, the literal blueprints for everything we see in the cosmos today. And this is absolutely crucial. See, if the early universe had been perfectly smooth, we wouldn't be here. There'd be no galaxies, no stars, no planets. It would have just stayed a boring, featureless gas forever. But it's not perfectly smooth. When we look really closely at that glow, we find these incredibly tiny variations in temperature, little hot spots and cold spots that are a direct map of tiny density differences in that primordial fog. And that is how everything began. Those slightly hotter, denser spots had just a tiny bit more gravity. And over billions of years, that tiny bit of extra pull was enough to gather more and more matter, eventually building up into the vast cosmic web of galaxies that we see today.
It all grew from those little ripples. And to see them, scientists have launched a whole series of amazing space missions, like COBE, WMAP, and most recently Planck, to take progressively sharper baby pictures of our universe.
And by analyzing the patterns in those ripples, the exact size of the hot and cold spots, how they're spread out, we've actually been able to figure out the precise recipe for our entire universe. And the results are honestly mind-blowing. It turns out that all the ordinary matter, the stuff that makes up you, me, the stars, everything we can see, is less than 5% of the total cosmic budget. The rest is made up of stuff we can't even see, mysterious dark matter and the even more bizarre dark energy.
So that brings us to the very frontier of cosmology today, because as much as the CMB has told us, it still has secrets to reveal.
The next deep layer of information isn't just in the temperature, but in the light's polarization. Think about polarized sunglasses. They only let light with a certain orientation get through, while the light from the CMB also has an orientation, and it shows up in two very distinct patterns that scientists call E modes and B modes.
Okay, so we've already measured the E modes. They're pretty well understood. They come from the same density ripples that create the temperature spots. But the B modes? The B modes are the holy grail. They are the big prize. Why? Because they're thought to be produced by something truly exotic: gravitational waves, actual ripples in the fabric of space-time itself, generated by an event called cosmic inflation. So cosmic inflation, this is the theory that in the very first, tiniest fraction of a second after the Big Bang, the universe underwent this insane, faster-than-light, exponential growth spurt. It's a wild idea, but it explains a lot. And finding these specific swirling B-mode patterns in the CMB would be the smoking gun. It would be direct evidence of the gravitational waves produced by that event, confirming one of the absolute cornerstones of modern cosmology, and giving us a peek into the very first moments of existence.
And so the search goes on. Right now, new telescopes are being built, pushing the absolute limits of sensitivity, all to keep listening to that ancient echo. They're hoping to tease out those final, faint secrets of our cosmic birth, all to answer that ultimate question. Buried in this ancient light, could we finally find the clues to how everything, absolutely everything, began?